Welcome to solverfy.
Hello students, here a copper rod and a silver rod are connected in series like this, and they both have same length, that is L. Copper rod having the length L and the silver rod also having the length L, and they both have the same area of cross section A, and the copper being the hottest temperature and the silver being the coldest end. Here the copper end having the hottest temperature and is given as 86 degrees Celsius, and the silver end having the coldest temperature, and this is given by Tc 24 degrees Celsius, and the thermal conductivities of copper and silver is given. Thermal conductivity of copper is 390 joule per second meter per degree Celsius, and for the thermal conductivity of silver is 420 joule per second per meter degree Celsius. In this case, we have to find the junction temperature. So at this temperature we have to find at this junction we have to find the temperature. Since these are taking place under steady state conditions, the heat current that flowing through the two metals will be the same. So equating them will get the result of the junction temperature. So the equation for heat current is thermal conductivity of copper into area into Th minus Tj, where Th is the hottest temperature, Tj is the junction temperature, divided by L, and this will be equated to the heat current of the silver rod, which is Kag into area Tj minus Tc by L. By plugging in the values, we can calculate the junction temperature, and here the area and length being the same, they cancel out each other, and here it is 390, which is the thermal conductivity of copper. Th is 86 minus Tj is equal to 420, which is the thermal conductivity of silver, into Tj minus 24 degrees Celsius, which is the coldest temperature. And if we simplify, this term will reduce to 13 times and this term will reduce to 14 times. Now multiplying inside, so 13 into 86 will give 1118 minus 13 Tj, which is equal to 14 Tj minus 336. And if we solve, we get 1454 is equal to 27 Tj, and as a result, if we divide this value by 27, we get the junction temperature as 53.8 degrees Celsius. This is for first case. And for the second case, now the rods being interchanged, that is the silver rod comes front and then the copper rod. Here the hottest temperature and coldest temperature remains the same as it is. So Th is here, Th is 86 degrees Celsius, and Tc is here, and this is 24 degrees Celsius, and the thermal conductivities remain the same. In this case, we have to find the junction temperature if the rods are interchanged. So here we can use the heat current formula, that is, in this case the hottest temperature corresponds to the silver, so Kag into A Th minus Tj by L is equal to the coldest temperature corresponds to the copper into area Tj minus Tc by L. Here the area and the length being the same, they cancel out each other, and 420 into Th is 86 minus Tj equal to 390 into Tj minus 24. So again, if we simplify, we get 1204 minus 14 Tj is equal to 13 Tj minus 312. Bringing the variables to one side and the values to another side, we get 1204 plus 312 equal to 27 Tj and Tj is equal to 1516 by 27 equal to Tj. As a result, we get the junction temperature in this case as 56.15 degrees Celsius, which corresponds to 56.2 degree Celsius. So this is our required answer. Hope you find this video is useful. Thank you.